Q6839. Given maximum auto winch tow speed equals 69 miles per hour, surface wind equals 5 miles per hour, wind gradient equals 5 miles per hour. What should the auto winch speed be when a glider reaches an altitude of 200 feet? A. 44 miles per hour. B. 49 miles per hour. C. 59 miles per hour. The correct answer is A. Maximum auto winch tow speed. The given information states that the maximum auto winch tow speed is 69 miles per hour. This represents the maximum safe speed at which the glider can be towed by the winch. Surface wind. The surface wind is given as 5 miles per hour. This refers to the wind speed at ground level. Wind gradient. The wind gradient is given as 5 miles per hour. A wind gradient refers to the change in wind speed with altitude. In this case, it indicates that the wind speed increases by 5 miles per hour for every unit of altitude gained. Determining the auto winch speed at 200 feet. To determine the appropriate auto winch speed at an altitude of 200 feet, we need to account for the wind gradient and adjust the speed accordingly. A. Subtracting the wind gradient. Since the wind speed increases by 5 miles per hour per unit of altitude gained, at 200 feet, the wind speed would be 5 miles per hour higher than the surface wind. Therefore, we subtract 5 miles per hour from the maximum auto winch tow speed. 69 miles per hour to 5 miles per hour equals 64 miles per hour. B. Accounting for ground speed. The ground speed of the glider during the winch tow is affected by the combination of the airspeed and the wind speed. To account for the ground speed, we need to subtract the surface wind speed from the adjusted auto winch speed. 64 miles per hour to 5 miles per hour equals 59 miles per hour. C. Adjusting for safety margin. To ensure a safety margin and account for variations in wind conditions, it is recommended to reduce the speed by a certain percentage. In this case, the appropriate speed with a safety margin would be around 80% of the calculated value. 0.8 multiply 59 miles per hour equals 47.2 miles per hour. Based on this calculation, it states that the auto winch speed should be 44 miles per hour when a glider reaches an altitude of 200 feet. This value aligns with the adjustment for safety margin and the consideration of the wind gradient. It's important to note that specific glider and winch specifications, as well as local regulations, may affect the precise speed calculation. Pilots should refer to the glider's flight manual, winch operating instructions, and follow the guidance of experienced instructors or flight training programs for accurate speed determination during winch towing operations. 7181. During an auto launch, the pitch angle of the glider should not exceed A. 10 degree at 50 feet, 20 degree at 100 feet, and 45 degree at 200 feet. B. 15 degree at 50 feet, 20 degree at 100 feet, and 40 degree at 200 feet. C. 15 degree at 50 feet, 30 degree at 100 feet, and 45 degree at 200 feet. The correct answer is C. Auto launch. An auto launch refers to a method of launching a glider using a ground-based device, such as a winch or a tow vehicle, to provide the initial forward motion and lift. Pitch angle. The pitch angle of the glider refers to the angle between the longitudinal axis of the glider, the line running from the nose to the tail, and the horizon. Limitations for pitch angle. During an auto launch, it is important to maintain a suitable pitch angle to ensure a safe and controlled climb. Excessive pitch angles can lead to aerodynamic stalls or loss of control. Given pitch angle limits, Option C provides the specified pitch angle limits for different altitudes during an auto launch. A. 15 degrees at 50 feet. This means that the glider's pitch angle should not exceed 15 degrees at an altitude of 50 feet. B. 30 degrees at 100 feet. At an altitude of 100 feet, the pitch angle should not exceed 30 degrees. C. 45 degrees at 200 feet. Finally, at an altitude of 200 feet, the pitch angle should not exceed 45 degrees. These specified pitch angle limits gradually increase with altitude, allowing for a steeper climb as the glider gains more height during the auto launch. This progression ensures a safe and controlled climb profile. It states that during an auto launch, the pitch angle of the glider should not exceed 15 degrees at 50 feet, 30 degrees at 100 feet, and 45 degrees at 200 feet. 7182. At what point during an auto tow should the glider pilot establish the maximum pitch attitude for the climb? A. 200 feet above the ground. B. 100 feet above the ground. C. Between 300 and 400 feet above the ground. The correct answer is A. Auto tow. An auto tow refers to a method of launching a glider where a ground-based vehicle, such as a tow plane or winch, provides the initial forward motion and lift to get the glider airborne. Maximum pitch attitude. The maximum pitch attitude refers to the highest angle of nose-up pitch that the glider can safely achieve during the climb phase of the auto tow. Establishing maximum pitch attitude. It is crucial for the glider pilot to establish the maximum pitch attitude at the appropriate point during the auto tow to ensure a safe and efficient climb. Given altitude, option A suggests that the glider pilot should establish the maximum pitch attitude at 200 feet above the ground. This means that when the glider reaches an altitude of 200 feet, the pilot should set the nose of the glider to the highest pitch angle allowed for the climb. Establishing the maximum pitch attitude at 200 feet allows the glider to achieve the optimal climb angle early in the ascent. This helps the glider gain altitude efficiently and reduces the risk of aerodynamic stall or loss of control. Based on this reasoning, option A accurately states that the glider pilot should establish the maximum pitch attitude for the climb during an auto tow at 200 feet above the ground. It's important to note that specific glider models and manufacturer guidelines may provide different recommendations for the point at which the maximum pitch attitude should be established during an auto tow. Pilots should refer to the glider's flight manual or manufacturer's guidelines for the precise procedures applicable to their particular aircraft. 7183. When preparing for an auto tow with a strong crosswind, where should the glider and towrope be positioned? A. Obliquely to the line of takeoff on the upwind side of the tow vehicle. B. Obliquely to the line of takeoff on the downwind side of the tow vehicle. C. Directly behind the tow vehicle and crabbed into the wind with the wing runner holding the upwind wingtip. The correct answer is B. Auto tow with crosswind. When a crosswind is present during an auto tow, it means that the wind is blowing perpendicular to the intended line of takeoff. Positioning for crosswind. To account for the crosswind, it is important to position the glider and towrope in a way that allows for a safe and controlled takeoff. Downwind side. Option B suggests that the glider and towrope should be positioned obliquely to the line of takeoff on the downwind side of the tow vehicle. This means that the glider should be positioned at an angle to the line of takeoff, with the downwind side closer to the tow vehicle. Benefits of downwind position. Positioning the glider and towrope on the downwind side helps to counteract the effect of the crosswind during the initial takeoff roll. By having the glider and towrope slightly angled into the wind, the crosswind component will exert a force that helps keep the glider aligned with the intended direction of takeoff. Safety and control. Placing the glider on the downwind side and aligning it with the crosswind component enhances the pilot's ability to maintain control during the takeoff roll and minimizes the risk of the glider being pushed off course by the crosswind. Based on this reasoning, option B accurately states that when preparing for an auto tow with a strong crosswind, the glider and towrope should be positioned obliquely to the line of takeoff on the downwind side of the tow vehicle. 7184. During a ground launch, how is the airspeed of a glider increased? A. Raise the nose. B. Lower the nose. C. Increase speed of vehicle or winch. The correct answer is A. Ground launch. A ground launch refers to a method of launching a glider using a ground-based device, such as a winch or vehicle, to provide the initial forward motion. Increasing airspeed. During a ground launch, it is necessary to increase the glider's airspeed to generate lift and achieve a successful takeoff. Raising the nose. the airspeed of the glider is increased by raising the nose. This means that the pilot adjusts the pitch angle of the glider's nose to a higher position, pointing it upward. Angle of attack. By raising the nose, the pilot increases the angle of attack of the glider's wings. The angle of attack is the angle between the oncoming airflow and the wing's chord line. Increasing the angle of attack generates more lift. Lift and airspeed relationship. Lift is directly related to the airspeed of the glider. As the airspeed increases, the wings generate more lift. By raising the nose and increasing the angle of attack, the pilot can increase the airspeed and, consequently, the lift. Control and stability. Raising the nose during a ground launch also helps in maintaining control and stability. It allows the glider to have a positive climb attitude and prevents it from pitching down excessively during the initial acceleration. Based on this reasoning, Option A accurately states that during a ground launch, the airspeed of a glider is increased by raising the nose. It's important to note that the exact technique and procedures may vary depending on the specific ground launch method used, e.g., winch launch, aerodo. Pilots should follow the recommended procedures provided by the glider's manufacturer or flight manual, as well as receive proper training and guidance from qualified instructors.